Respected all, myself Raju Bhandari and my paper ID is 154. Today I am going to present my research work on modified mobility aware MAC algorithm to improve the lifetime of dynamic wireless sensor network. The authors for these papers are Raju Bhandari, that is myself, KR Nirmal, Dr. MR Sangvi, DS Rajnoor and Amit Brahmecha. And this research topic is under the guidance of Dr. K. Rajasekhar sir. This is the outline of my research work or of my presentation. Here the title, origin of research, the literature, finding the research gap, problem statement, objective, conclusion and references. This is what the title here, the priority mobility aware routing clustering algorithm for extensive dynamic wireless sensor network to improve the lifetime. As we already know, nowadays, whatever wireless sensor networks are available, that is very, very dynamic in nature. They are changing their positions very, very frequently. And for that, there is a need of what? The improved routing protocol as well as mobility aware routing protocol. There is a need of that. There is a need right now in the market. That's why we are proposing this particular system. What exactly the wireless sensor network is? The wireless sensor network we can simply define as the spatially distributed sensor networks which are ad hocly placed in the different environment. Those sensors are collecting the values from the physical environment and that is stored onto the server. This we can simply say that is the wireless sensor network. The characteristics of wireless sensor networks are distributed sensing and processing. As all sensors are distributed at the remote areas, they are sensing the values from the environment and they are sending to the base station. Scalability again is the matter of concern. Then security, privacy, mobility, power efficiency, heterogeneity, and homogeneity. So multiple characteristics are there for the wireless sensor network, but our main target is there on mobility and power efficiency. Our main focus is there on mobility and power efficiency because the battery is very fastly drained. And in order to prevent that particular problem, we are finding out the solution for that. So out of these characteristics, we are focusing on mobility and power efficiency. See, what are the challenges while operating or while dealing with the wireless sensor network? So energy, coverage, limited bandwidth, decentralized management, MAC layer issue, data collection, scalability, design are multiple challenges up there. But the parameters or the challenges which are highlighted in blue color is our main area of concern, and we are focusing on that. So what are the different types of communications are there? Node is going to communicate with the base station. Here there is a direct communication from one node to the base station. Okay. Similarly, in wireless sensor network, multiple nodes are placed and all multiple nodes are going to communicate with the base station directly. There is a direct communication between node and base station. The second type of communication is node base station. In this case, what happens? One node which is at the lowest level, which is sending the data to their intermediate node, and intermediate node is sending the data to the base station. And the last technique is node cluster head and base station. As we already know, nowadays clustering plays a key role in multiple type of communications. So here we are creating the clusters. Let's say we are having the 100 nodes with us. So we are creating the cluster of 2020 or 25 nodes, and those nodes are going to communicate with each other through cluster head only. That means cluster head is elected there. Those who are having the highest energy level, those nodes are selected as a cluster head, and the rest of the nodes are sending their data to the cluster head, and head is going to communicate with the base station. Then, so what exactly the mobility aware protocol is? So there are two types of protocols are available there in the market, that is, or two techniques are available, that is synchronous and asynchronous. So what happens in synchronous? Again, common sleep active read, then slotted TDMA, hybrid MAC protocols are the techniques which are there under the synchronous category. And in asynchronous, preamble sampling is there. So what is synchronous? Synchronous is the method in which the sender and receiver, means base station and nodes, are synchronized their timing, and during that timing only they are going to communicate it. Then in the slotted TDMA, what happened? The channel is divided into time slot, and during that time slot only, the respective nodes or members are sending their data. The third one is the hybrid MAC protocol. The common sleep active and slotted protocol, both are combined into the hybrid MAC protocol, and that is our main area of concern here. In hybrid MAC protocol, the advantages of common as well as the limitations of slotted aloha and common active sleep active period are overcome in the hybrid technique. And the second technique is asynchronous. In asynchronous, there is no common sleep active period. Okay, all are communicating as per their convenience, and that data is transferred over the network. So in 2009, that is IEEE paper, the authors Haya and Ben Otham proposed one protocol, that is MIMAC protocol, to overcome the limitations of MMAC protocol, because MMAC is mobility media access control protocol, and this MIMAC is mobility aware media access protocol. So in that they have selected or they are selecting the cluster head by using the leech algorithm. Okay, and but as leech are having their own few of the drawbacks, and that drawback we need to overcome in our proposed system. Then what are the observations from that paper? The first and fourth phase, as shown in the presentation, will create the additional computational overhead, and because of that additional computational overhead, what happened? The lifetime of the wireless sensor network goes on decreasing. Then SYNC, as this technique is based on the synchronous category, so in that case there is a need to share the SYNC packets also, and that SYNC packet creates the additional overhead. So ultimately we can say whatever techniques they have proposed in 2009, that is best at that time, but with some disadvantages, and that disadvantages we are trying to overcome in our system. Then the next, in 2015, the Vidya Janani and Ganesh Kumar published their work in Hindawai Journal, and they have proposed two algorithms, that is EECSS and HEF techniques, that concentrate on the network-wide cluster head creation and energy management. But the issue with that is cluster head routing table as mobility is not handled. That means this particular, whatever techniques they have designed, that is for the static network. Once the cluster head is selected, that cluster head will be used for the longer time. Okay, so in that way, that algorithm is working. And in 2018, the Zari and et al. Published their work in Springer, and they carried out the detailed survey of mobility conscious MAC protocol. In that case, they are considering the GPS based mobility, then pediatrician mobility, vehicle mobility, that means multiple mobility parameters they have considered, and from that they observed MIMAC hybrid protocol having some comprehensive computational overhead, and that we need to focus in our work. Then yeah, so in 2015, Hoon et al. Proposed the slotted multiple sense protocol to create the MAC topology. It uses the CSMA-CA techniques, but this technique gives the better result in the dynamic environment. They're using tree topology. So tree topology uses the multi-hop component issue in that, because in this tree topology, what happened? There is a sequence of parents, then grandparents, then parents, and then child. So through multiple nodes, they are going to communicate. Okay, so that is again the issue with the Hoon et al. Paper. So that we need to recover. So this is what the literature that I have done for this particular system, and in that there are three techniques are generally used, that is common schedule, slotted TDMA, and the next one is the hybrid MAC. And if we compare almost all the systems, there is that means they have addressed many more issues, but again the computational overhead issue is again one of the biggest issue that they are facing, and the selection of cluster head in rotation, that is again one of the major challenge that is imposed by these many authors. So in order to overcome that particular drawback, there is a need of new protocol, and that protocol we are going to focus. So another part with the MAC protocol is the sleep scheduling. As I already told you, mobility handling and cluster head creation is that task is done with the help of static network only in the previous work, but our main concern is to handle the dynamicity, because network is scaling at the large extent. The nodes are leaving the network, joining to the another network. So some of the networks are getting died because of their battery power is getting drained out. So along with that, in order to improve the lifetime of the network, there is a need to improve the sleep scheduling algorithm also. So multiple sleep scheduling algorithms are available nowadays in market, but those multiple sleep scheduling algorithms are having their fixed structures. So in 2018, Zhou Zhang proposed the three categories of sleep scheduling, that is synchronous, semi-synchronous, and asynchronous. So in synchronous, semi-synchronous consumes more energy in terms of packets and generate more delay in the system. In terms of asynchronous, each node has its own sleep and wake up schedules. That also is the point of concern. So they have proposed very good survey in 2018. After that, Diong Ye and Zhang, that is the IEEE transaction paper, they propose the sleep adaptive wake up scheduling approach, which does not use the duty cycle concept. So nowadays there is machine learning is very famous concept, and that reinforcement learning they are using in their structure, and because of that the packets or their sleep schedulings are handled very well with the help of the technique which is proposed by the Diong Ye and Minji Zhang. Then in 2018, the Runze Van and Etiol presented the energy efficient sleep scheduling mechanism with the similarity index, and they are using the fuzzy logic. But the drawback with their paper is that redundant node can be scheduled into sleep shed for the next round, and because of redundant node, there is again a huge consumption of energy. So again, literature survey is produced, and under this survey many more techniques are there, and again almost all techniques are facing the issue of what common sleep awake scheduling problems and all. Then priority is again one of the major concern that we are planning to propose in the next paper. And during this priority, because as many of the wireless sensor networks are transmitting the higher priority data first and lower priority data later on, but that is again not the solution. So in some of the application, every node should get the equal priority to transfer the data. So we are working on that also. So this is all about the literature of priority. Then the finding from the literature survey is that so need few modern energy efficient approaches to improve the lifetime of the network. Then sensor node demands self-organization due to randomness present in uncontrolled non-deterministic topology. Theoretical estimation is there, but there is no practical solutions. Clustering solution can suggest sleep awake schedule for the WSN to reduce the power consumption. Reclustering and re-election is one of the major challenge that we need to focus. So problem definition, we are planning to propose the protocol that will easily select the cluster head, reduce the ideal listening, improve the throughput, packet delivery using reinforcement machine learning algorithm. So this is what the research gap here. Our main work is dynamic cluster head selection, node mobility handling, leaving joining operation of the network, and then self-healing sleep scheduling. Whatever algorithms are available that are not self-healing, so we are planning to propose the self-healing, self-scheduling reinforcement options. So this is what the objectives of my research. This is the first objective, and already paper is published on that. This is the second objective. On that also paper is that is published. See the system architecture. If we observe here, the base station is located at the center location. In the second diagram, base station is located at the different location. That means the coverage and whatever base station is there, base station is also mobile in this case. All are changing their positions very frequently. If you observe here, see here, node leaving one zone and joining to the another zone. So if one of the node is leaving the zone 3 and zone 1 and want to join to the zone 3, then they can easily move from zone 1 to zone 3. In that case, and the zone 2 node willing to join to zone 1, then that is also easily going to join the zone 1. So in that way, the things are there. So this is what the algorithm I have proposed for the creation of cluster head and for handling the leave join operation. And the everything is based on the probability distribution, and probability distribution select the best cluster head, and for re-election and re-clustering purpose, this algorithm gives us the proper result. So this is all about what the work that I have done for our algorithm, which is proposed for the cluster head selection. And then the next algorithm is there for the leave join operation. So here the operations like leave join and shifting operations are handled very well with the help of this particular algorithm. So the third our third area of concern is to elongate the lifetime of the network by using the self-healing approach. So in the self-healing approach, we are using the reinforcement learning approach, and this reinforcement learning approach is based on is working on the penalty and reward strategy. So during this penalty and reward strategy, if that means the next step, what next step the node will take, whether it will go into the sleep state or whether it will go into the wake up state, that is decided automatically without considering the ideal time and all. So if whenever the node is having data and that data you want to transfer, then and then node will go into the sleep, into the wake up condition and then transfer the data. Otherwise it will be in the sleep mode for the longer period of time. So this will definitely save the energy, and because of that, this approach, a reinforcement learning approach, our most of the work is getting easy, and it will definitely save the huge amount of energy. So here as I already told you, it works on the reward and penalty basis. So cluster head and node scheduling is done based on the reward and penalty, and their states are also decided automatically. This is what the algorithm. This is what the reinforcement algorithm proposed using the Q learning algorithm, and here we are deciding the reward and penalty policies. Then these are the results. Here I have compared the Macron algorithm, which is our proposed work, with the RIMAC, ATMA, AODV, and MEMAC. So the parameters that we have considered here is the delay, then throughput, then packet delivery ratio, and many more. And in all cases, the MEMACron are performing quite good if we compare with MEMAC, AODV, ATMA, and RMAC. This is the packet delivery ratio. Packet delivery ratio is quite high if we compare with the MEMAC, AODV, and all. The throughput is also quite considerable good, because if we compare the basic AODV is giving throughput in terms that means good throughput they are generating, but it consumes a huge amount of energy and battery will get drained very fastly. But in that case, the average throughput we are getting with the help of this particular part. Then average energy consumption, obviously the average energy consumption is less if we deal with the Macron. Then Macron, the hop count, as I already told you, only cluster head directly communicating with the base station. So only 2 hop distance is required. In the rest of the cases, the hop distance required is more. This is the mean deviation. And from that, we can easily conclude that the Macron algorithm is using the dynamic sleep-wake scheduling algorithm gives us the better result in case of delay, throughput, then mean deviation, packet delivery ratio, and all. And we are getting a very good input, and it will definitely improve the lifetime of the network. So these are the references for the work. And with this, I will stop my presentation. Thank you, the team of International Conference, for giving us the opportunity to present our work. Thank you so much. Thank you.